Let's go through an example together where we graph a cosine function that has a reflection. For this example, we have f of x is equal to -3 times cosine of x. Let's start by looking at the formula for the cosine function and identifying the values of a, b, c, and d. Rewriting our function into this particular formula, we have f of x is equal to, and then for a, we're going to have this -3 out in front. We're going to go ahead and multiply that by this cosine function, and let's see what we're going to have inside here. Well, it looks like b is just going to equal 1. It's going to be 1 multiplied by the quantity of x minus whatever c is. We don't see a value for this particular function, so c is going to be 0. And then we're going to go ahead and close this off. And then afterwards, let's go ahead and add d. In this case, d doesn't seem to be there, so it must be 0. And so we know that a is -3, b is 1, and c and d are both 0, which means there's not going to be any translations left or right or up or down. To tell if this function is going to have a vertical reflection, that depends on the value for a. So if a has a negative value, which in this case it does, then we're going to say, yes, we do have a vertical reflection or reflection across the x-axis. As for horizontal reflection, or flip across the y-axis, that's dependent on if the value of b is negative. In this particular case, it's not here, so we're not going to have a horizontal reflection, just a vertical reflection. As for the amplitude, that's going to be dependent on the absolute value of this a value, so the absolute value of -3, that's going to equal +3, so that's our amplitude. For the period, we're going to take 2 pi and divide that by our b value. Now we know our b value here is equal to 1, so 2 pi over 1 is just equal to 2 pi, so the period's not going to change here. Now for our midline, that's dependent on the value of d. Since d is 0, then our midline is still going to be at y equals 0, that horizontal line. The minimum y value for this function is going to be the midline, or 0. Go ahead and take away the amplitude of 3, so 0 minus 3 is going to be -3. That's the minimum y value. And then for the maximum y value, we'll take our midline and go ahead and add the amplitude, so 0 plus 3 is going to be a +3. That's our maximum y value. Now for this particular function, since we don't have any translations left or right, and we also don't have any horizontal translations at all, we can go ahead and write our start and end points as well as the 3 points in the middle that are helpful. So these aren't going to be changing in this particular example, so we're starting at 0 and we're ending at 2 pi. So that means halfway in between is going to be pi, a quarter of the way is going to be pi halves, okay, or pi over 2, and then we're going to have this 3 pi over 2. That's going to be 3/4 of the way through this period. And so for the parent function here, these are going to be the 5 points that we always graph. And remember, this graph starts up here, moves to the midline, moves down to the minimum, back to the midline, and then back up to the maximum. So just make sure you kind of have this shape in the back of your mind as we go ahead and graph our current function. All right, let's see the values of a, b, and c and how they kind of impact this function here for the table. So we know the x values for the parent function, but what about the x values for this particular function? The only variables that could have an effect on that are going to be b and c, but since b is 1 and c is 0, which have no effect, then we're going to have the same x values. So our x values are going to stay the same, but what about our f of x values? How are those going to be altered? Well, that's going to be affected essentially by a and by d, right? Now d is not going to have any effect on it because d is equal to 0, but a will have an effect on it. It looks like we're going to have a reflection. We said that because it was negative, and it's also going to be a vertical stretch because it's being multiplied by a factor of 3. Basically, let's just take each of these y values and multiply each of them by this -3, and those are going to be our new y values. 1 times -3 is -3, 0 times -3 is still 0, -1 times -3 is +3, 0 times -3 is going to be 0, and 1 times -3 is -3. Now that we multiplied all those y values by -3, we're ready to graph this function. All right, here we go. All right, here is our coordinate plane. Our midline is going to stay put in the middle along the x-axis. Our minimum y value is going to be at -3. And our maximum y value is going to be up here at +3. Now that we know our midline and kind of our upper and lower boundaries of this function, let's go ahead and plot our points. Here's 0, -3. Pi over 2, 0 is right here. Pi, +3 is up here at the maximum. 3 pi over 2, 0 is back at the midline, and then 2 pi, -3 is going to be down here back at the minimum. Then trying to draw a smooth curve through each of these points, this would be one period of this function. And if you wanted to sketch additional periods for this function, you would go back to the midline to the right, then to the max, then to the midline, back down to the minimum. On the left side, you would go back to the midline, then the max, midline, minimum, midline, max, midline, and minimum again. Here's what 3 more periods of this function would kind of look like if we just went and continued that pattern. Alright, so there you have an example of how to graph a cosine function that has a reflection across the x-axis as well as a vertical stretch. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.